Welcome to LabMinutes.com. In this video, we will look at how to configure site-to-site VPN on a Cisco router and an ASA firewall using a pre-share key authentication. In the second half of the video, we will see how we can use an access list to control the traffic that's come across the tunnel, both on the router and the ASA. So now our lab setup, we have an FW1, which is an ASA firewall on one side, and a router R2 on the other side. We're going to try to establish a site-to-site VPN between a VLAN 32 and a VLAN 128. Okay, so start off with a configuration on the firewall. Okay, so the first thing we want to do, we want to make sure that there's no restriction as far as the access list that the VPN traffic might be put through. And the command is sysauth connection permit VPN, and this command should be there by default, and what it does is it tells any kind of VPN traffic that comes across the tunnel will be bypassed as far as the access list that you have inbound on the outside interface, so it will not get checked against those access lists. Okay, next we want to make sure there's a route from the firewall to a router. So I'm going to do route outside, and the router R2 has an IP address of 2.2.2.10, so 222.10. I'm going to do a host route with the next hop of 1111. Okay, and then we'll ping 222.10, and there's switchability. So usually when you configure an ASA, there's three main components that you need to pay attention to. One is routing, two is access list, three is NAT. So we just took care of the access list to make sure that there's nothing blocking our traffic. We also took care of the routing, so we have all the routes to the other side router. Next we're going to take care of the NAT. Although on the new 8.3, 8.4 software by default, there's no NAT. So basically everything can pass right through untranslated. But I just want to show you if in case you have a NAT configured already for something else. So we need to configure what used to be called a no NAT or NAT exemption equivalent on the ASA. But here, since we're running the 8.4 software, we need to do, we choose to do twice NAT to do a NAT bypass. So first we're going to configure the object group network. I'm going to call real HQNet. So we call the VLAN 32 as HQ network with the network object 172.16.32.0.0, and then we're going to define real site net, which is the VLAN 128, and that will be 128. Next, we use those object group in the NAT itself with the NAT inside, outside, source, static. So if you have other NATs configured in section 1 already, which is the section we're about to put this NAT in, you might want to define the line numbers to make sure this particular NAT statement get matched first. So for example, you put 1 with source static, and then here it asks you to enter the object group. So for the source, it's HQNet, and since we're not translating, we're gonna also use the same object group for the mapped address. And then with the destination static, that's gonna be when it goes to a 128 VLAN. Okay, so we're not translating that, we just want to match it and use it as being as a condition, but we're not translating anything. So again, we enter itself twice as far as real and mapped IP, and that should be it. Okay, next we create a access list that we're going to use for the crypto map. So it's a crypto access list. I'm going to call VPN to site. Standard permit IP 172.16.32.0 going to 172.16.128.0. Okay, so usually, although if you want to restrict traffic between the tunnel, that goes over the tunnel to only to certain TCP UDP port, you still do not want to define the ports here in the crypto access list. You will instead later on define a separate access list that you will then apply to the tunnel itself, which we will look at later in this video. So here in the crypto access list, you just want to keep it from IP to IP. Okay, so let's see, show run access list. Okay, so we got that. Next, we want to create a phase 1 policy. So crypto IKEv1 policy 10 with authentication of pre-share key, encryption AES 256. Hash SHA. We're going to do group 5 and lifetime of 86400. Okay, next we're going to do crypto ISACAM. Here we're going to do disconnect notify. So you enable notification when it tries to disconnect. It tells the other side. And the last thing we want to do for phase 1 is enabling it on the outside interface. Okay, next we move on to the phase 2 configuration, crypto IPSec IKEv1 with a transform set, ESP AES 256, and SHA. And our option is ESP AES 256 and ESP SHA HMAC. Okay, if you choose, you can also do a DF bit clear DF. So any packet that has the DF bit set and exceed the MTU, we can go ahead and clear that, but you still need to deal with the fragmentation. But at least your packet doesn't get dropped. Okay, so next we're going to do crypto map. I'm going to call VPN map with a sequence 10. And first we will match. Okay, so we matched this will match the interesting traffic. So we're going to use the access list earlier that we create called VPN site. So this is the crypto access list. Now that we have matched, we will set. Here there's quite a bit that you can set. You can set IKEv1 with the transform set. Right here. Next we can do, you can enable NAT transversal if you want. Just going to leave it intact. Next we can set peer, and the peer IP for us, which is R2 IP, is 222.10. You can set reverse route. Okay, so we can do set reverse route. And you can set security association. Lifetime second, we're going to do 8 hours. And for the lifetime kilobyte, yeah, do 1 gig. Okay. And let's see what else we can set on the tunnel. Oh, PFS. So we're going to do PFS group 5. And since we're not doing certificate, there's no need to set trust point. So that should be it. And then we will activate your crypto map on the interface outside. Okay. Next, we have to define a tunnel group. And when you do a site-to-site VPN, for the most part, if you do pre-share key, you want to use IP address. You have to match the IP address of the peer for the tunnel group. And here's we have 222.10 type. it is an IPSec LAN to LAN. Okay, now we have to configure an IPSec attribute with IKEv1 pre-share key. So this will be a pre-share key that will be used for both sides. Just do Cisco. Okay, so that should be all you need. So if you do show run crypto, here's our phase 2 configuration. Just gonna skip ahead, zero the certificate that we have installed on the ASA, and then here's the phase 1. Okay, so that's all we need for the firewall side. Next, we're gonna go ahead and do the router R2 side. Start off with make sure there's a route to the other side or the firewall IPs. Although there might be a default route on the device, you might still want to consider putting a more specific route. So 2221, which is the next hop, so the IP is .11, and then for R2, the next hop is 2221. And give it a name also. So there'd be HQ VPN. Next, same concept. We need to define the crypto access list to match the tunnel interesting traffic. So we'll call VPN HQ permit IP 172.16.128.0. Instead, we're going to have to use the reverse subnet mask to 16.32.0. Again, reverse subnet mask, IP only, no ports. And we do crypto ISACamp policy 10 with encryption AES 256, authentication pre-share key, group 5, hash and lifetime will leave it default 86400. Next we do crypto ISACamp key. So this will be the pre-share key with the unencrypted clear text, and specifically to this particular peer for 111.11. And so it's a good idea to put no XAuth, just in case you have a dynamic crypto map or other kind of crypto map configuration that requires XAuth. So then we do crypto ISACamp keep alive for the date pair detection 10.3. Interval 10 retried 3 times. That's phase 1. So phase 2 with the transform set ESP AES 256 SHA, which is called the same name. And then you got ESP AES 256 and ESP SHA HMAC. Okay. Just like we did on the other side with the DF bit clear, we can also do that on the router. Clear. Next we configure crypto map, also called VPN map, with the sequence 10, and we want to use ISACamp for key exchange. We go through the configuration starting with match. So match interesting traffic with the ACL we created. VPN is called HQ. Next we do reverse route. You do QoS question mark. You might want to do QoS pre-classify. So if you choose to do QoS on the tunnel interface, or actually the physical interface where the crypto map is tied to, the QoS pre-classify makes the original traffic header or packet header to be visible to the router, so it can match a correct with this class map policy map that you created for QoS. Again, not a bad idea to use that as part of your template with QoS preclassify. So it's set. We go set peer. There would be 111.11. On the other side, set security association, lifetime kilobyte, 1 gig, lifetime seconds. You can see we're trying to match the configuration on both sides, just to make sure there's no discrepancy, and that might later on results in the connection not coming up. Next we do set transform set. Okay, set PFS. I believe we did group 5 on the other side. Okay, that should be it. Then we tie the crypto map to the interface, outside interface fast01, and now that's on. Okay, let's clear the screen real quick. Here on debug crypto ISACant 127 in the firewall. Now on the PC and VLAN 128, we're gonna initiate a ping. So ping 172.16.32.1. See there's some activity in the background, and the ping succeeded on the second try. Let's keep it going. Alright, let's turn off debug on the firewall. Take a quick look. Okay, as you can see IP 222.10, and you can see connection landed in the tunnel group 222.10 because we defined an IP for the tunnel group name, and that's how it matched it. And you can see right here, phase 2 completed. Show cry IPSec SA. Then we have encrypt decrypt packets. Show VPN session L2L. It's give you a little bit more information as far as what time it was locked in, and the duration has been out for almost 1 minute. Okay, now that we have the connection established, the next thing we would like to try is to start playing around with access lists that or start restricting traffic across the tunnel. So in addition to ping from the PC, let me try to telnet as well, just to show you it works. Password Cisco, and now we are on switch 1 coming from the PC behind R2. Okay, so that's connection is across the VPN tunnel. So let me exit. So first let's take a look at the VPN filter features on the firewall side. Okay, first we're going to define the access list. It's called from site, and we want to permit ICMP only. And in addition to that, we're going to go deny anything else. This is for the traffic coming across the tunnel from R2. IP, any, and we're going to lock it so we can see. Okay. So next we're going to have to get under group policy because that's where the command is located. And then keep a consistent name, 222.10. And go attributes. And the command that you want is VPN filter with a value of from site. Okay, so this would be an inbound into firewall 1. And then we need to go back into the tunnel group, and for the default group policy, you point to the tunnel group we just created. So same name. Okay. So once that applies, we have to reset the tunnel. So clear crypto IPSec SA. Just make sure it's completely gone. Yep, no state. So let's go ahead and ping again. While that ping is going, it's already gone to QM idle. Okay, so the ping is coming across no problem. But let's try the telnet again. Okay, so right here, the telnet is not getting through. And if you look at show lock, do you have lock enable? I do not have lock enable, so let's do this. Locking buffer 7. Let's try that again. Oh, locking on also. If you look at show access list, here you can see the 16 permitted ICMP, but we also at the same time get a deny, also 6 hits, and that's our telnet being denied. Okay, I'm just trying to see if we can locate that deny message right here. Deny TCP for user coming from an outside 128.32 and 232.1 on port 23, which is telnet. So that is being denied. One thing I forgot to show you is the NAT table before. So let's do show NAT. So here, it seems to have, let's see, show run NAT. Get rid of that real quick. So right here, show NAT. See, there's untranslated hits 106 times because we initiated the traffic from the outside. So if you were to initiate traffic from the inside, you would see a translate hit. So let's do that with switch 1 ping 172.16.128.4. Let's make sure there's a route for that. Oh, I have to source from VLAN 32. There you go. Okay, so ping went through from R2, from switch 1 to R2, subnet 128. So if you show NAT again, here we have a 5 translate hits. Okay, so you can see our NAT statement is working. Now going back to our access list configuration, we have successfully configured a VPN filter with access list on firewall 1 that's blocking everything but ICMP packets. So now let's do the same thing on R2 or similar to that. First, we're going to create an access list. So we want to block an ICMP echo coming from firewall 1 or VLAN 32, but we want to allow everything else. So before we tested with switch 1 ping, it went through no problem. So now we're going to see if we can block that. So IP access list, call it from HQ, deny ICMP any, and we want to specifically block echo. We're going to still permit IP ICMP any, and we'll see if we can get some access list hits for the echo reply. Actually, it should have been permit ICMP any. Okay, and then we go permit IP any for everything else. Okay, now where you would apply the access list is actually under the crypto map, VPN map. We use sequence 10. The question mark it's under set IP access group. Okay, and under here, this is where we tied our access list, which is from HQ. And just like any other interface, you can specify the direction as well. So in being inbound into the tunnel from the outside, and out being outbound of the outside tunnel. So from, we're going to do in, so because we want to block anything inbound from the tunnel. Let's see if that takes effect right away, otherwise we might need to clear the tunnel. So ping. So it looks like for the router, as soon as you apply the access list, it takes effect pretty much right away without having to reset the VPN tunnel. And immediately we get a deny log messages with ICMP coming from 32.1. So you get a deny packet. Well, if you try to initiate a ping from a client PC and VLAN 128, it's still working. So if you do show access list, here we have a 5 deny matches, and at the same time we also have an echo reply matches. So just keep in mind that the router, access list on the router is not stateful, as far as you need to make sure if you do both inbound and outbound, you allow appropriate traffic in both directions. Unlike the firewall where it's stateful, so you can see here echo request reply is treated separately unless you use things like CBAG or zone-based firewall that keeps a state of your traffic connections. Okay, just to show you the right here, we also have the crypto access list that we use to match interesting traffic, and there's a lot of matches. And on the firewall, right here, VPN site, we also get some hit counts on that as well. So that's how the the device know what traffic it needs to encrypt it, encapsulate, and put into the IPSec tunnel. Okay, so it's pretty straightforward. The most important thing is you want to make sure those crypto ACLs are pretty much almost identical, but in reverse order as far as source and destination, but everything else should match to make sure everything works properly. Okay, so that's pretty much wraps up our video on the site-to-site IPSec tunnel between a Cisco router and ASA using pre-share key authentication. Thank you for watching LabMinutes.com. I'll see you guys in the next video.